Okay, since everybody is here, let's start with the BGP presentations. As I can see, all in this call have submitted their assignments. So Shrecha, Digvijay, Kuber, and Momita all have submitted. So that's a good thing. Kuber, let's start with you. Please present the BGP assignment.
Sir, actually, my laptop is not working, and I will join with my phone. So, shall I present it next week?
Yes, please. I
Okay,
expect
thank you,
next.
sir.
Thank you.
Thank you.
Kuber, Mr. Kuber.
Yes, sir.
Go ahead. Please present the PPT. बाहर हो क्या कुबेर?
हाँ सर।
हम्म तो फोन से ज्वाइन किया है. Okay. Momita, any such case or you can present?
Sir, I can.
Great, go ahead. Straight away full marks.
Sir, is it visible?
Yes.
Sir, uh, now I'm presenting our assignment number 5,
Mm-hmm.
which is Border Gate Protocol.
Okay.
What is Border Gate Protocol?
एक सेकेंड मोमिता, ये फुल स्क्रीन है क्या?
Just
नहीं. So that then I'll know कि मेरे इसमें I'll change the view. From your side, is it full screen?
no, sir, it's a tab.
Uh, ठीक
Sir,
है,
just
चलेगा.
a minute.
Yeah,
Just
it's
a
okay,
minute. I
fine. You can
share the
continue.
full screen.
नहीं, जैसा है वैसा ठीक है. You can continue. शेयरिंग बंद हो गया.
So now it's okay.
Yes.
What is Border Gate Protocol? Border Gate
Hmm.
Protocol construct an autonomous system graph based on the information exchanged between BGP routers. This
Hmm.
protocol allows router to exchange routing information and it enables them to share their knowledge of routers and reachability. The Border Gate Protocol was created to support the interconnection of multiple private internets, such as those found in a corporate network. Now we see how it works. The Border Gate Protocol is a dynamic routing protocol that allows routers to share or routing information. Here we see our autonomous system 100, 200, 400, 500, and 300. They in the border gate protocol they share their routing their routing information with each other. Router in the routers in the BGP protocol exchange routing information, which is changed periodically over TCP/IP connections. When a router receives a packet, it looks up to the next address in its routing table. Here we see our autonomous system 100 that has a packet and which next hop which uh, which path is AS 500. Uh, we want to share a packet from AS 100 to AS 500. Uh, at first, the AS 100 share wants to pair her with 200, and after then it share its information. Then the AS 200 shared the information to AS 400, and then go on. If the next hop is not directly connected, it sends a message asking to pair or routing to set the packet to the closest router. Then once the packet reach their final destination, they exit the network via the same interface as the original packet entered. In this picture, after the packet from AS 100 to AS 500 um, is reached, then they exit the network via the same interface as the original packet is entered. Now we see the functions of border gate protocol. Here is initial peer acquisition and authentication. BGP allows the right peer to be identified, authenticated, and connected to making the network run more efficiently. Sending of network or positive reachability information. BGP sends information regarding whether or not a peer is reachable. This saves time by eliminating errant connections. Verification that peers and the network connections between them are correctly functioning correctly. Once a connection happens, BGP is able to verify the health of the communication. In this way, BGP facilitates more consistent, reliable connections. The types of messages which BGP use, that is open to negotiate and establish peering. Then update, which is used to exchange routing information. Keep alive, which is used to maintain peering sessions. Then notification, which is used to report errors. Now see some advantages of gateway protocol. Border Gateway Protocol enables efficient routing by determining the best path for data packets to reach their destination. This ensures that data takes the most optimal route resulting in fast and more reliable communication. BGP is highly scalable, allowing the internet to accommodate the immense growth of internets and users. BGP supports multi-homed connectivity, meaning an organization can connect to multiple internet service providers simultaneously. BGP gives organizations control over their internet traffic. They can influence data flow by setting policies and preferences in the routing decisions. One of the most significant benefits of BGP is its role in enabling global connectivity. There is some challenges and security concern in BGP protocol. BGP can be vulnerable to security threats such as route hijacking or malicious attack, leading to potential disruption and unauthorized traffic diversion. BGP configurations require expertise and careful planning to ensure proper implementation and optimal routing. Although BGP itself is a standard protocol, there can be variation in its implementation across different vendors and network devices, leading to potential interoperability challenges. BGP operates on a decentralized model where routing decisions are made autonomously by routers. This lack of centralized control can make it challenging to enforce global routing policies or address routing consistencies. Thank you.
Okay, thank you so much. That was good. Anybody else who willingly wants to present? Okay, I guess not.
Should
In
I
that,
stop sharing?
yeah. You can stop sharing. Okay, in that case, if you guys paid attention, what is autonomous systems?
Sir, a
No, no,
big net.
you don't answer. Others.
Okay, sir.
What are autonomous systems? Okay, give me one example of an autonomous system. ठीक है. Uh, may I know after TA2, is there going to be a TA3 or is it like the final exam?
So
Sir,
maybe
there will
final.
be final exam.
Okay. How many marks is it? I'm assuming it's to be 70 or is it 50?
Maybe 60. I
Okay.
don't know.
Okay.
I don't know. Maybe it's
So basically they haven't told you yet.
Yes, sir.
Okay. ठीक है. I think it will be 50, but let's see. Just give me a minute. So we'll take one lab today, small one, and then we will continue with our syllabus. Okay. Again, very simple. Very simple lab. Already on the topic that we have seen. Okay. We have gone through it long before, probably in unit 1 or 2. I don't remember, but it's regarding ARP. Okay, so we are going to set up ARP in Cisco Packet Tracer. Now, ARP doesn't need to be set up because it's a basic protocol used by everybody to do what?
Sir, to find MAC address.
Right. Great. Okay. So I'll, I mean, newly I will simulate. Let's open a new file. Okay. If the new doesn't work, I will show you on the already made uh, setup. Okay. Have you guys downloaded Cisco Packet Tracer? Do you have it? I mean, at least one of you. That's my expectation. Best.
Yes, sir.
Awesome. Anybody else? Yeah, that's what I thought. Okay, so you go to end devices on the bottom panel. And what are end devices? That's our PCs, laptops, smartphones, servers, and so on. Okay, so pick any number of PCs you want for this setup. I will pick up 3. If you remember, during theory, while explaining you what ARP is, I had a figure where I had one PC and then a switch and it was connected to a router. Okay, that's the same setup. It's just that we are making it on a Cisco packet tracer for it to work. Okay, this is a server. Again, not necessarily that you need a server. You can take a router or you can just keep it blank. You can just have 3 PCs with a switch because ARP is a internal protocol. It does not work across networks. Okay, it is within the network to get the MAC address. So now we have our endpoint devices. We need our network devices. We have routers, switches, hubs, wireless devices, and so on in network devices. Since our goal is only to have a communication between all the endpoint devices, just for the sake of connection, we are going to use a switch. We will use 2960. Okay. Routers are used for communication between networks. I am not having 2 networks. This is a single network. All I'm doing is connecting them. So I need a switch. These are the wires over here in connections. This is the automatic. Sorry. Okay. This is the automatic connection. If you have something specific in mind, you can choose of these. You have console, copper straight, copper crossover. I think you have fiber also somewhere. Supposed to be phone. Yeah, this is the fiber. If you're well versed of what you want to do, what you want to try, you can pick up a specific connection. Okay, normal connections. If you see this orange dot, it means it is still not up. Okay, it is still not active, it is still not running. Green is up. If it is a red triangle at downwards, it is down. The network is down. Okay. If even if I try to send a message from here to here, it will fail. Why? Because I have not set the IP address. So either give it some time to, like I said, to turn into green, or you can send a message from one PC to another so that it turns green. It will fail a few times because it takes time to set up. But once that is done, if everything is set up right, it will work. Okay. Now, I'll just put on some labels. 192.168.0.1. I don't intend to put this server on a different network. I'm going to keep it on the same network. Hence, all my IPs will be within the subnet 192.168.0. Okay. Next over here, before that, let's copy this. Right now, I'm just putting labels. I'll put this as 2, this as 3, and this as 4. Okay. If I put this as 192.168.1.4, its network is going to change based on the automatic subnet mask that the setup calculates, that the Cisco packet tracer calculates. It will be 192.168.0.4 and the subnet mask will be you want to see what the subnet mask will be? Let's set up. Okay, before that. Okay, you go to server, you go to desktop. In desktop, you'll get IP configuration. Make sure that it is set up to static because you are going to set it on your own. Okay, so we go 192.168.0.4. You click somewhere on the gray part and you get a subnet mask automatically calculated, which is 255, 255, 255.0. If I had put 192.168.1.4, this would have been on a different network. What do I need to do to make sure that it is on the same network in spite of having the address 192.168.1.4? Yes. What I mean is, right now it is 192.168.0.4. This is 255.255.255.0. Hence, right now it is on the same network as that of those PCs. Okay. If I change this to 192.168.1.4, the network or the subnet is going to change. What do I need to change to make sure that this subnet remains in the same network as those of the PCs?
Sir, we only have to change the host address. The host part.
नहीं, मुझे होस्ट एड्रेस नहीं चेंज करना है विदाउट चेंजिंग द होस्ट एड्रेस. लाइक ये जो 1.4 है, आई वांट टू कीप इट एज इट इज, एंड इन स्पाइट ऑफ दैट आई वांट टू मेक श्योर कि ये मेरा सर्वर यही सबनेट में है, इसका नेटवर्क नहीं चेंज हो रहा.
Sir, नहीं पता.
Okay. एक hint that an IP address consists of a network portion and an host portion. All zeros in the host portion means it is a network address. And I want to make sure that this stays in the same network address. तो इसके बेसिस पे तुमको नेटवर्क एड्रेस मिल रहा है क्या? अगर वो मिल रहा है तो उस नेटवर्क एड्रेस के अंदर ये वाला होना चाहिए. So try to find the network address.
सबनेट मास्क 255 255 00 करना पड़ेगा.
255
255 255 0.0 255.255.0.0.
Yes, that's great. Correct. Right answer. Okay. अब क्या हो गया? Because of this, this becomes my network portion, and this is my host portion. अब इसकी वजह से क्या होगा? Everything will come under 192.168. Now it doesn't matter यहाँ पे तुम 14 लिखो 24 लिखो, क्या होगा? Because everything is under this network. So this server automatically comes under this network. So now my PCs are at 192.168.0.1, 0.2, 0.3. My server is 1.4 and still it is in the same network. If I don't change the subnet mask, I need to have 0.4. I cannot have 1.4 because यहाँ से उसका network change होता है. Okay, great. So Prathamesh understands. I hope the rest of you do too. Where was I? ठीक है. Server 0. Yeah, we have set up its IP address. Let's set up PC zeros. Okay. It was, again, you repeat the same procedure for all devices. 168.0.2. Click anywhere else, subnet mask is calculated automatically. Close the window. You don't need to save, it gets saved again automatically. This IP is 192.168.0.1. Done. And last. One 192.168.0.3. Okay, everything is set up. Now let's try to send a message from here and here. Successful. So at least the configuration is correct. Successful. The configuration is correct. Do the same for all PCs and just one for the server. Most probably the same is reflected for other PCs as well. But if you are in doubt, you can do the same for all PCs. Now, let's go back to the simulation. So simulation part is here to see how the message goes. Now, these are the list of protocols that go on. This is too much and we cannot go through everything. We are only concerned with two, which is ICMP and ARP. ICMP, why? Because that is what we are going to use to showcase ARP. ICMP is nothing but ping, and ARP is the protocol that goes on previously, as in before ping, in order to get the MAC address. The rest of the protocols you can ignore or you can just edit out. You go to edit filters, you have IPv4, IPv6, and so on. Okay, so for example, I will just remove all this because we don't need it. It's a hectic annoying process because you have to do it one by one. There is nothing to deselect all. Same goes for miscellaneous, and I am not going to do all of these, but you get the idea. Okay, you remove it and you get the remaining protocols. When you are doing it, if you want to refine it, just include ARP and ICMP. The simulation will go on for all the other protocols that are there. How, like, first it will take ARP, then will take ICMP, CDP, spanning tree protocol, and so on. It will go on and on. Okay, until all those basic default protocols are executed. You can stop after a ping or just edit out the filter so that you see only those two and the experiment will be over. Okay. Next, so you open up any PC of your choice, you go to command prompt, and there you type first. Okay, first let's type arp -a. This is the command to see the arp table. Okay, sorry, I had it already. Is this the, this was a new file, right? Okay, anyway, so the arp is supposed to come blank. Okay, but since I had run it already, even though this is new, I'm not sure why uh, it's coming like that. Let me see how I can flush the ARP table. Okay, let's try clear IP ARP. Okay, this is an invalid command. Just give me a minute. Let's try clear ARP. Okay, it's D. -a. Great. No ARP entries. Okay. So if you see in the beginning, it's no ARP entries, and that's what it's going to be. This is the cached data, previous data. Okay. Now, let me clear this again. Delete. This delete is for the messages that you sent here down. Let's open PC0 again. You go to command prompt. If you see ARP table is gone and you say ping, you can ping any PC of your choice or you can ping server. Our server is 192.168.0.4. Press enter, and this is what? This play button will give it automatically. If you want to speed up, just press this. Okay. Okay. Now, if you see, our first is ARP. Okay. You see, you go to outbound details. Sorry. PC switch 0. Last is switch 0 to PC 1, PC 2. Okay. I think I skipped. Yeah, I skipped a process. Anyway, so the first ARP message goes to the switch. The ARP message then goes everywhere because if you remember, okay, I'm gonna pause. If you remember, ARP message is what? To get the MAC address. So first it sends the packet to everyone asking who has IP 192.168.0.4. Hence the message goes to everyone. Now, if you see there is a cross on these messages, it is because the PCs do not have IP 192.168.0.1. The only device that has this address is this one, and hence there is no cross because it has accepted the packet. Okay. If you click on any, this is the layer wise how the packet is going. If you want to see a particular packet, you go into inbound, and if you see, you have source MAC address, source IP address, which is our 192.168.0.2, but the target MAC address is all zeros. because we don't know the target MAC address. It is yet to come. So we are going with ARP first so that I get the target MAC address. Once I get it, my ping message will go. Okay? After that, I will send, as in my PC will send the ping message. If you see, the target IP is there. Okay? So target IP, I know, that is why this message is accepted and the other two are crossed, as in not accepted, because that is not the IP. And then the server sends back his message with the MAC address. So this is the last one. If you can check it over here, which packet is where. Last device is server 0, so this was the last device. Currently it is at device switch 0, which is this one. And what is the protocol? It is ARP. If you open it up, go to outbound details. Now you should see source MAC address, which is of this server. Okay, you have the IP and you have the target MAC that is given. This is of the server. Source MAC address is, sorry, of the PC0. You have the target of the server and you have the target IP, which is like giving back giving back the PC0, telling him that, hey, my MAC address is so and so. So next time when you send the ping message, make sure you include this in the packet. Okay, let's go. He gets back. Now the ICMP starts, which is, as in our ping message starts, which is the purple one. This one goes. If you open this packet up, okay, not that here. Let's go to the destination. Should be here now. Okay. If you don't find it here, you will find it in the OSI model over here. Okay. 0010.11aa.e871. Okay, that's the MAC address. Source of a PC is 00E08447, so on. Here it should come, but okay. Oh, sorry, it is an ICMP, that is why it doesn't come. You will see it in the ARP protocol. Okay, since it is the ICMP message, you will see it on the OSI model layer, the MAC addresses on layer 2. You won't see it in the packet. The only time you'll see it in the packet is during the ARP message, so that the PC knows what the MAC address is. This will run 4 times because our ping gets 4 times. Okay, I'll just fast forward it. Yeah. Now this ping is STP. This is spanning tree protocol. This is not of our concern. This is just because all these defaults protocol run one behind the other. That is why I said, you can stop it right here. And if you don't want it in this simulation, just edit the filters from here, remove the protocols that you don't want, and you're good. The only thing you will see is ICMP and the ARP messages. So I am going to close this. Let me reset it automatically and see 4 times. Okay. So our ping message is done 4 times. Now, if you check the ARP table, okay, ARP-A, you have it. Okay. For internet address 192.168.0.4, which is our server, this server. This is our server. For that server, we have our physical address 00E0 and so on, MAC address and type dynamic. Okay, let's try to see if this works from year to year. Hopefully it is a ping message, and in the ARP table, we will have another entry. Okay. Yep. So 192.168.0.1 has a physical address of 000BBE90CD5E, which is of this PC. Same for this PC. And if you want to clear the ARP table, just go with ARP-D. This will flush out the ARP table. No entries found. Okay. The -D is working in Cisco Packet Tracer. I tried previous clear IP ARP and these commands, but these are not working here. So if you're doing it in some other application on program, different command will work. Is going to go. So you are going to have it over there. Okay, extremely simple, nothing difficult. But if you still have any doubts, please let me know. This was a new one, so I'll just close it. I'll give you guys a minute to think. Tell me if there is any doubt. Otherwise, we are finished with 3 labs. Please go through the previous recordings to see which the other 2 were if you don't remember. Excuse me. Okay. There are 2 more labs left. One is regarding natting, and one is regarding finding out malicious URLs, links, or IP addresses based on third-party tools. So the one which is based on third-party tools is you don't have to do anything. It's everything is on the internet. But I am waiting for the manual to be prepared to see if there is any other method, because uh, like I said, it's not like the Cisco Packet Tracer where certain things are to be done as stepwise or instructions is purely free game. You can do it however you want, interpret as per the different websites or third party applications that you use to perform the particular analysis. Okay, so that is even easier than this one, but I don't think that would be asked in exam. Okay, the other 4 would be. Next. Okay, next is broadcasting request. So in a computer network, there are various ways in which we can transmit data from one node to another node, one node to multiple nodes, and many node to many nodes. Okay, so one of the examples is radio and ARP, the example that we just saw. It was broadcasting because if you remember, the first message of the ARP that goes, it goes through everyone because he needs to know the MAC address. So if you recollect, I'm sure you do, we just did it. The first message, the green message that went, it went to everyone. So that is nothing but broadcast. Okay. The green message went here, it went here and here. These 2 were rejected because their IP addresses did not match. This was selected because it did. It is nothing but broadcasting because one PC sent the message to everyone in the network. Okay, that's an example of broadcasting. A similar real life example, which is visible, which is known to all, is radio. You tune in to a particular frequency, for example 98.3, and you hear a particular person talking. That is one PC telling it to all. So one-to-many communication. For node to node, it is called unicast, also known as point-to-point communication. Example is cell phone conversation. When multiple point-to-point communications are made, it is called multicast. The message is received by only those hosts who choose to be a part of the multicast group. Example, video conferencing, sending a message targeting number of people at a time. For example, WhatsApp group. One person sending it to all is nothing but an example of multicast communication. In our syllabus, it is broadcasting. Okay, one node to all nodes is broadcasting. So broadcasting in computer networks is a type of communication mechanism that allows the message to be received by all the nodes of a network. Broadcasting signal works at layer 2. Okay, ARP is again the example. So I'll show you a demo in Cisco Packet Tracer. If you see, this is orange, so it's not active. These PCs are. Let's try to switch them on. You send a message, it will fail because it's orange, but trying to get it up as soon as possible. Let's wait. Yep, they're up. Okay, my interface is up and ready for communication. So let's go to desktop, command prompt. If you need a simulation, we'll have it on. Okay. Okay. So what do I need to do to send a broadcast message in this scenario? Let's start. I need to ping something so that everybody gets the message. For example, everybody needs to tune into the radio frequency 98.3 in order to hear the music or the person saying something. In similar way, what do I need to ping so that the message is broadcasted to everyone? Okay, if just to the IP address is this, I'll write it over here. Sorry. It was 192.168.0.23 and the subnet mask is 255.255.255.0. Hoping that I'm correct. Yes, I am. Yeah. So now you have hints. Tell me how it should go. You have an IP address of this machine. This machine intends to send a broadcast message. A broadcast message is something that is sent to everyone. Basically, a message being sent to everyone is broadcast message. So what should I ping? Another hint being, what are the types of addresses? What are the types of IP addresses we have? What are the types of addresses we have, guys? So, okay, guess I am not going to go ahead. We can end the session here only.
So, so network address.
Okay. What I mean, so the question is, what are the types of addresses? Network address is one of those address. What else?
So host address, broadcast.
Mhm. Yes, good. Okay. So these are type. Private, public is also type. It's type is just a word I'm using to define different ways of the particular IP address is used. So you're correct. So we have network address, host address, broadcast address, private, public. So based on that, what should I be pinging? Because I want to send a broadcast message. I'm not asking for a particular IP address. In general, in English, what should I be pinging to send a broadcast message? Okay. If others are not there, I'm kicking others out. What should I do? ठीक है. So I will be pinging what? Broadcast address, because I want to send a broadcast message. So what I will be pinging a broadcast address so that the message is sent to everyone in the network. I am sure तुमको broadcast address पता नहीं होगा. If you can tell me, I'll wait another 2 minutes. If I want to send a message to everyone in the network, I have to send it on the broadcast address. Hence, the broadcast address exists. In this case, what is the broadcast address?
So ping ping broadcast address. The whole
No,
message.
that's just I have written it so that you guys understand. But ping cannot be done to a word. It has to be an IP address. So what is the IP address which I need to ping? I've just written ping IP address in order to for you guys to understand. But ping IPv4 address. This is the format. This is the format of the ping command. Okay. It needs to be ping some IP address like 192.168.0.23, which is our this PC address that way. So what broadcast address I should ping so that the message is sent?
So what is the subnet mask?
Yeah, this here. So our PC from which we will be sending, it's 192.168.0.23 and the subnet mask is 255.255.255.0. Okay. I'll just show you if it works. Mostly won't work in simulation because I'm sending a message from one PC to another, but hopefully yeah, message sending does not work in simulation. Okay, you figure it out. Okay. Sorry, where is the chat? Yeah. Ping broadcast address. This broadcast address needs to be IPv4. It cannot be the English letters, English words broadcast address. Figure out what it needs to be. Okay. Next. 255 is a special broadcast address, this entire 255, which means this network. It lets you send a broadcast packet to the network you are connected to without actually caring about this address. In this, it is similar to 127.0.0.1, which is the loopback address, also known as localhost. I have again posted what it means to be a network address, broadcast address, and host address. Next. In real equipment, it enables a port to send traffic to a host addressed with all ones. This reaches all hosts on that subnet. For example, we could have an interface with address this, enable broadcast address and send packet to that address. Okay, it will be broadcasted to all hosts on that interface. It will use a destination MAC address FFF. It is recommended to turn it off for security reasons because it has potential for a denial of service attack. Directed broadcast is a giant security hole that should be avoided, so it is not included in packet tracer. So what it means is that you have an assignment. Can I send broadcast address to another network? Okay, explain. Okay, so this is your assignment, that I want to send a broadcast network from one machine, from one network to another. Okay, try and sending it. I'll show you. Okay, this is my network. This is one network. This is two network. This is the router for connection between networks. These are my IP addresses. Okay, I'm just giving you a your next assignment will be creating this setup and trying to send a broadcast message from one network to the another. You will tell me what your results are and why those results have come. Okay, so assignment 7, broadcast message from one network to another. Explain the results. Explain hyphen slash show the results. This is your assignment. I don't want a PPT or a Word document. You will show it to me in Cisco Packet Tracer. You will set it up and show me. Okay. Broadcast message from one network to another. Explain, show the results. That's it. इसके आगे कुछ नहीं. Conclusion, introduction, ये वो कुछ करने की जरूरत नहीं है. Just try to send and you will explain what has happened, why it has happened, and so on. This is your assignment 7. And next Sunday, which is 1, will be the submission. Okay, again, you cannot, I don't want the files on mail. I am not going to open them on Cisco, each and every file. I want this to be presented. So if you present it, show me on in the class itself, that will be your submission. As in, I will consider that you have submitted the assignment. Otherwise, it's a no. Okay. Maximum, I think I can give 1 or 2 days for as a late submission. I will consider those late submissions, but again, the submissions have to be on call. Okay, they have to be presented. You can set up a meeting if you want, but that would be it. So you have 7 plus 1 or 2 days. Last submission date is Sunday. Apart from that, the other assignments will be considered as late submission. So you won't get full marks. Full disclosure.
Is it on class or another meeting?
Sorry?
So should I present it on class or another?
Yeah, in class, like how you showed the PPT, same way you will show it to me in class, present it. All I'm saying, it's not going to be on PPT, it's going to be on Cisco Packet Tracer, like how I showed you here. I opened the application, I showed you the lab, right? That way. You can already have the setup. You don't need to set it up in front of me. You can have it set up ready and you can show it. Of course, you are free to use anything you want. You'll find hundreds of videos on Google, YouTube, and other tech forums. Okay? There are videos, photos, and many things, articles, documentation, FAQs. The person itself, the customer support itself will help you to set it up if needed. Okay, so there is no what do you say, lack of material. Key points on broadcasting: data is sent to all node stations in the network domain. A special broadcast address exists for every network which is used to receive a broadcast message. Not every device wants to receive the broadcast message. It generates the most network traffic because the broadcasted message is sent to every node in the network. It is less secure. A sensitive message shouldn't be sent to everyone, and hence it should be kept in mind before broadcasting a message. So broadcasting is generally not done because it is not secure. Other examples are DHCP and R. Real life or examples which are different from computer world are um this radio for broadcasting. Can you give me an example for unicast apart from cell phone conversation on similar lines?
So
Another
like
example is
sending WhatsApp messages.
hmm, yeah, okay, sure. That one is too. That is also a unicast point to point. Okay, great. Advantages. So it is ease of communication. If you want to deliver one single message to everyone, it saves a lot of time and process overhead. Network troubleshooting. You can easily identify the corrupt resources and potential security threats in a large network. Okay, reduce network traffic. Un Unlike unicast, which separately sends a message to each node in a network, one by one, resulting in high volume of traffic. Multicasting requires additional network infrastructure and can be complex to manage. Broadcasting doesn't require any additional networking infrastructure and can simultaneously send data to all nodes in a network without increasing traffic. Okay? Broadcasting in Linux. I do not have the machine set up or to show you. I'll show it to you next time. Okay? I'll get the machine running, VM running, and I'll show it to you there. But otherwise, to give you an idea, it all works on command prompt. So for example, I don't know if you have ever been to a cyber cafe, but generally from the command prompt itself, the person can control all the machines. He can send a message like 5 minutes are left or something like that. And it gets broadcasted to all the receiving nodes, letting them know that how much time is left for their session. Okay. So that is an example. I will show it to you next time how it actually works. Or you can try it yourself also. Go on an online interpreter and just type it out. The only point is that it will happen on your same machine. You won't get uh, it differently on a VM. Another thing you can do is you can have multiple tabs open with multiple clients, but it may or may not work because depends on the connection and to the server how it is going. Okay, so if it is going to the same server, what I mean is if you open up different clients, okay, as long as they are going to the same server, it will work. But if they go to different servers, you won't get the result because he doesn't know who are in the session. ठीक है, वो broadcast के लिए not necessarily same इसमें हो आप लोग जब multiple ये करोगे. So try it on the same uh, terminal, same machine. If you can get your hands on a VM, that would be great. Otherwise, I'll show it to you in the next session. So broadcasting is remaining. I'll just note it down. I'll just put it in chat. Broadcasting in Linux pending. Okay. Next. So alternatives to client server architecture. This is theory part, so there's nothing to show. I will just go through the theory. If you have any doubts, we can discuss. Okay. Since there is, I cannot show you, I cannot have the doubts clear. That is why I said that we can discuss this. Okay. In the PPT last year, there were some doubts from people from your previous batch. I had included it. Just let me see. Okay, I think this additional info, yeah, this additional information or doubts is from your previous batch. So when I give you the PPT, you can have it, or you can ask me, alag se, I will send it to you on mail, no problem, whenever you want. Okay. So alternatives to client server architecture are client queue client and peer-to-peer architecture. There is also another one which is called the service oriented architecture. So there are three different architectures which are an alternative to our client server architecture. I hope you all remember what client server architectures are. So client queue client architecture. In this, we have endpoints, servers, and simple clients, also referred to as passive queue architecture. So every endpoint, all endpoints, including servers, are simple clients. It developed from trying uh, to make one client a server for different clients, thereby multiplying potential usages for clients. Client queue client architecture uses a passive queue to allow client instances to communicate directly with each other and refine their requests from servers. Servers act as passive queues, which can be, for example, a relational database, also central to traditional client server networks. A client queue client or passive queue system is a client server computer network in which the server is a data queue for clients. Instead of communicating with each other directly, clients exchange data with one another by storing it in a repository, the queue on a server. Clients can read data from and send data to a server that acts simply as a queue to store the data. This allows client to distribute and synchronize files and information. This is sometimes known as passive queue architecture. In simple words, in client server architecture, there was a requester, okay, and there was a service provided. Since this guy is providing a service, he was known as the server. There is a client and there is a server. This is the client server architecture. Now what happens? I have a server. That server has a data structure called queue. Okay, this is the server and this is the queue. And it has clients. In this case, even a server can be a client. Okay, even a server can be a client. Previously, server was only one who was providing services. In this case, it along with providing a service, it can also make a request. And where does that request go? That request goes to back to the main server or to the data structure called queue. Okay. Now, so how it works is, for example, let's talk about Microsoft OS updates. Everyone knows this, everyone gets this. So there is a big server in the United States and it has a queue. This queue has a memory, and in each memory, there is an update of the OS. let's say it is OS 15.1 version software. This software is there in each portion of the memory. This is also sometimes called as satellite server. Satellite. I think I've messed up the spelling. Satellite server. And it has sometimes a directly connected PC, which is highly unlikely because there are previous servers before. What are those servers? So for example, this will be a server of, let's say, Facebook, because Facebook uses Microsoft as well. This is, let's say, the Indian government. Okay. So we all have servers. And from this servers, okay, this is a server. And from this server, again, we have multiple PCs. So what does data structure architecture does is client queue client is whatever updates are sent to you, okay, are taken one by one from your memory. I have put this 7 because 7 simultaneous connections can be made, for example, okay, which makes this a, if you remember, concurrent servers. We had done this on Friday, concurrent servers. It is going to handle 7 connections. Each connection is going to provide them an operating system of 15.1 version. So in this case, it goes directly to the PC. And in this case, it first goes to the server of the Facebook company, of the Indian government, and then it gets passed down to the PCs automatically. All you have to do is restart your machine and everything gets updated automatically. Okay. So clients can read data from and send data to a server that acts simply as a queue to store the data. So directly to the PC, or in this case, these servers that are in between, they are simply acting as queue, which gather the OS data from the main server and pass it down to the machines so that they get updated automatically. This allows clients to distribute and synchronize files and information. So this file is getting distributed to all PCs and getting synchronized, because probably everyone will get a notification stating that your machine will be automatically restarted in 10 minutes and a newer version of Microsoft operating systems will be downloaded in your system. Okay. This is the kind of thing that happens. This is sometimes known as passive queue architecture. Okay. So sometimes there might be a server in between, or sometimes there might be PCs directly connected. As you see in the previous architecture, the server was providing services. In this one, it is not only providing a service to the PCs that are connected to it here down below, it is also requesting a service or a software from the main server, which is also known as the satellite server. Okay. So it is acting as a client as well. If you see here, all endpoints, including servers, are simple clients. Another example, web crawlers on different hosts need to query each other to synchronize an indexed URI. If you have doubts of what a web crawler is, I suggest you Google it. The client queue client approach is to store the indexed content from both crawlers in a passive queue, such as relational database or another host. Both web crawlers read and write to the database but never communicate with each other. It evolved into peer-to-peer architecture but is mostly obsolete today. Okay. This architecture evolved into evolved into peer-to-peer architecture. Nowadays, it is obsolete. It is no longer used. it is either gone to peer, or another is that it has become to cloud. So this type of functionality has moved to peer architecture or cloud. So nowadays, this OS distribution is done from peer to peer, as in I am giving it to you, you are giving it to your friend, that friend gives it to his family, and so on. So it becomes peer to peer. Another option is I go to Microsoft's official website and download it from there, which makes it a cloud based architecture. Okay. There is another example, which is web crawlers. You can Google what web crawlers are. Any doubts so far?
No, sir.
Okay. Okay. Peer-to-peer architecture. Again, I had given an example in the very start of the our subject, which was of BitTorrent. Okay, where each one of us is a peer, as in an endpoint, and we are only the servers. Client भी हम ही हैं और server भी हम ही हैं. Okay, we are both. We are consumers and we are providers. We give each other files and we download files from each other. Okay, this was in the beginning of our subject. It, you would find it very early in the recordings, so please do go. I think I have done it. It was used as an example. Okay, peer-to-peer architecture. I had explained it before, and I had used BitSite as an example. Okay. So theory part. Peer-to-peer architecture distinguishes itself by distribution of power and function rather than concentrating its power in the server. Again, there is no better example than BitTorrent. Okay, there is no server, there is no central server, there is no admin. We all are admins, we all are providers, we all are consumers. Okay, so there is a distribution of power and function rather than it being concentrated. Peer-to-peer models rely on power and bandwidth of participants. ठीक है, हमारा जितना bandwidth hai to provide something, okay, the faster I upload parts of files, the faster it is available for others. Okay, so that is what it means. It relies on power and bandwidth of participants. I am a participant, I have a file, I am going to upload it on as a magnetic link on the BitSite website, and from there it depends how fast parts of the files I upload, okay, and how fast you can get it. So it depends on the participants. A peer-to-peer network is a network of computers in which each computer can act as both a client and server. This model of network arrangement differs from the client-server model, where communication is usually to and from a central server. We download files from others, so there is no central server. Each one of us is a client and a server at the same time. Can you think of any other example? Okay, do think of another example and tell me next time. P2P architectures are designed to allow peers to share data with each other without the need of a central server. This can be useful for a variety of applications, including file sharing, anonymous internet browsing, and decentralized transaction ledgers. Okay. इससे तुमको कोई आइडिया आ रहा है एग्जाम्पल का? डिसेंट्रलाइज्ड ट्रांजैक्शन लेजर्स, एग्जाम्पल ऑफ पीयर टू पीयर आर्किटेक्चर। अच्छा, लेजर क्या होता है? चलो वो भी ठीक है। ब्लॉकचेन आएगा क्या इस एग्जाम्पल के अंडर? इस ब्लॉकचेन ऑफ पीयर टू पीयर आर्किटेक्चर?
Yes, sir.
ओके, हाउ? ठीक है। Blockchain is an example of peer-to-peer architecture, and it is based on decentralized transaction ledgers. ठीक है? How you will tell me? ठीक है, ये भी assignment next time. Decentralized transaction ledger, blockchain example. लेजर मतलब जिसमें अकाउंट्स लिखते हैं, ठीक है? तो द शॉपकीपर्स व्हाट दे राइट, ट्रांजैक्शंस, रॉ मटेरियल इतने का लिया, I gave salaries to so and so people, this much is my profit, this much is my loss, so much and so on. The book that he writes in, everything, these transactions that he writes is called the ledgers. Okay, transaction ledgers. Even your bank has a ledger. If you see, sometimes your bank refers to your transaction as the ledgers, um क्या कहते हैं, logs. ठीक है, so your transaction logs are kept in a ledger. It shows ki how much you deposited, how much you transferred, to whom you transferred, where, what. ठीक है, इसको कहते हैं ledger. Decentralized transaction ledger is where a bank is not involved. If a bank is involved, it is a centralized system. ठीक है, it becomes more like client server. You are the client, the bank is the server. In decentralized transaction ledger, there is no central server, so it becomes peer-to-peer architecture. An example is a blockchain. Why? Because the transaction of bitcoins or a virtual coin between two people is verified by third parties who are known as miners. What is Bitcoin mining? It is basically verifying a transaction between two people. Hence, that architecture, that technology comes under peer-to-peer architecture, and specifically something under decentralized transaction ledgers. Next, peers in a P2P network only have access to the data that they share with each other. Okay, server pay, for example, you will have different pages, right? You will have, for example, if you visit a website, you have access to its homepage, you have access to its products, you have access to its customer support, and so on. In peer-to-peer network, you have access to only what is shared. If I share you a movie file, you will have access to only that. You have access to nothing else. Okay, that magnetic link that I provided gives you very specific information, and you have access to nothing because you don't have access to my PC or a server. Okay, so whatever I share is the only access that you have. Peer-to-peer architecture is, sorry, a peer-to-peer network is a simple type of network where computers are able to communicate with one another and share what is on or attached to their computer with other users. Developed from the client queue client style, the P2P style allows the client and server to swap their roles in order to distribute and synchronize files and information across multiple clients. It extends the client server style through multiple responses to request, share data, resource discovery, and resilience to removal of peers. Some examples of a file sharing peer-to-peer network include BitTorrent, uTorrent, Ares Galaxy, FrostWire, and BitComet. They are almost the same as BitTorrent. It's just that there will be a few minor differences, but you can check it on your own. Do check it either on a VM or in an isolated machine or in incognito mode or through VPN. Okay? They might contain certain malicious codes or malicious users, malicious files that are being shared. So be careful if you are going to, I mean, if you're going to search more on these. A modern style architecture is web queue worker architecture style. You can find this in Azure Architecture Center. Sorry. Okay. Do give it a read. If you understand, well and good. If you don't, Google it. Okay. This is for self-study research purposes. I am not going to ask you questions on this. So whenever you can, go ahead. Service-oriented architecture. Service-oriented architecture is a stage in the evolution of applications developed and or integration. It defines a way to make software components reusable using the interfaces. SOA is not a technology, it is an architecture which most IT giants use to handle their enterprise more effectively and in a more agile way. SOA is a middleware solution which takes two or more systems or applications to talk to each other. Example, translator, ServiceNow. SOA is ServiceNow is a software application. You can check it online. SOA is loosely coupled architecture. It means when systems talk with each other, the dependency which is required to talk is minimal. Failure of one system does not impact the other system. Each service in SOA embodies the code and data required to execute a complete discrete business function. Example, checking a customer's credit card, calculating a monthly loan payment, or process of a mortgage application. The service interface provides loose coupling, meaning they can be called with little or no knowledge of how the service is implemented underneath, reducing the dependencies between the applications. One of the examples is software as a service. Although it comes under cloud architecture, you can probably classify or give it as an example of service oriented architecture, because if you listened carefully, a particular service is given to you as is given to you for usage. Okay, you don't need to know the underlying software implementation or anything. It reduces your dependency. You don't need to get every file, you don't need to have a particular operating system or anything. Everything is taken care of and only the software is given to you for usage. Okay, that is something of a service oriented architecture. Any other example that you can think of? Would API calling fall under this? Do you know what Postman is? It is a software application for API calling. Okay, that is something that would fall under service oriented architecture. This world's leading API platform. Postman is a single platform for collaborative API development. Okay, this is something. So you call APIs from here. This is something that would fall under service oriented architectures. Okay, there is not much to show on the, I mean, I cannot have architectures set up, but if you have any doubts, please do let me know. Like, these are the doubts from previous batch. Similarly, if you have any, we will discuss. I'll try to resolve them. Okay, you can think. Until then, let's go to see what they did. So the client server architecture is the most common distributed system architecture, which includes two main subsystems, client and server. Client server architecture can be classified into two models based on the functionality of the client. Okay, this is just some additional info and based on a few doubts that the previous batch asked. So if you have the same, well and good. If you don't, you can even mail me. Okay, if you don't have any in this lecture, you can mail me. I'll try to include them in the PPT next time. So there is something called as thin model client. All the application processing and data management is carried by the server. The client is simply responsible for running the presentation software. Okay, so all this new slide, table, cameo, shapes, icons, all these functionalities, they will have some software, right? They will have some functionality. In this thin client model, none of these functionalities are on my PC. Okay, when I click on them, the functionality is brought from the server. So if I say text box and I click over here, it means that the functionality is not existing on my PC. It was actually connected to a server and brought on my PC. Okay, something like it does not exist on my PC, the software, okay, does not exist on my PC. What happens? There is only a client which shows a link option. Okay, when I click on it, right, when I click on it, a communication goes to the server fetches the code, sends it back so that I can put whatever link I want in the PPT. Okay, that's what thin client model is. It is used when legacy systems are migrated to client server architecture, in which legacy system acts as a server in its own right with a graphical interface implemented on a client. Do you guys know what a legacy system is? A legacy system is an old method, technology, computer system, or application programming. So legacy system is something like जो बहुत पुराना है and everybody is using it and it is very important for the functionality. तो मान लो अब कैसे हुआ, for example WhatsApp is a legacy system. तो आगे जाके in 2050 the people who born and who are engineers, for them WhatsApp will become a legacy system because everybody is using it. It is very well established. It is almost correct. There is very less problems, and it's already new, like it's already on the best of the servers, best on the architectures, everything is up to the mark. Okay, state of the art jisko bolte hain. So if it cannot be done further for a few years or a new technology comes, then that system is considered, or that technology is considered as a legacy. a major disadvantage is that it places a heavy processing load on both the server and the network. Now, thick fat client model. In this model, the server is only in charge for data management. The software on the client implements the application logic and the interactions with the system user. अब thick इसमें कैसा है कि now only the data. So if this is my what do you say, PC, and I have file 1.ppt, 2.ppt. So the only thing on the server are these files. Kind of acts like a database. And the rest all functionalities जो तुम्हें यहाँ दिख रही है, home, insert, file, draw, everything, the software that it includes is on the PC itself. ठीक है? The software of PPT along with its functions is on this PC itself. So that is what a thick fat client model is. Most appropriate for new CS systems where the capabilities of the client, this is client systems, okay? Capabilities of client systems are known in advance. More complex than a thin client model, especially for management. New versions of applications have to be installed on clients. अब पहले इसमें कैसे होता था, अगर कोई अपडेट आया, लेट्स से आई इंट्रोड्यूस अ डिफरेंट टेम्पलेट, ये मैंने टेम्पलेट यूज किया है ना, ब्लैक बैकग्राउंड, येलो हेडिंग्स और ग्रीन, ये मान लो कि ये एक टेम्पलेट है. अगर मैंने कोई नई टेम्पलेट इंट्रोड्यूस की, मुझे सबसे पहले कहाँ लानी पड़ेगी, वो सर्वर पे, ओके, एंड कीप इट हियर in the previous model, which is thin client model. In fat client model, I do not store it on my server. जब मैं पैकेज डिलीवर करता हूं अपडेट्स का, उसमें मैं वो टेम्पलेट डालता हूं और वो टेम्पलेट स्टोर हो जाती है तुम्हारे पीसी में. कहां पे स्टोर होगी ये पता है, ऐसे ऐसे ये रहता है, प्रोग्राम्स, फाइल्स, स्लैश ऐप डेटा, स्लैश माइक्रोसॉफ्ट, और फिर उसमें बिन रहेगा, नहीं तो डेटाबेस रहेगा, नहीं तो लॉग फाइल्स रहेगा, दीज फाइल्स आर देयर. तो ये जो पाथ है ना, उस पे ये सब स्टोर होगा टेम्पलेट. You know right, this program files app data wala path. Yes, no, I mean this is not something, कोई calculation नहीं है इसमें. I just need to know if you are aware of it. Are you guys even in class?
Yes, sir.
Yes, sir.
ठीक है, दो लोग. The rest, ठीक है. This is about distributed systems. ठीक है, there is presentation layer, logic tier, data tier. Recording is going on. You can pause it. You can see if you have doubts. You can tell me later. It seems, I mean, the class is not interactive, so there's no point. Again, this is the slide. You can pause it, check it out. We are done. Broadcasting of Linux बचा है, वो मैं next class लूंगा. Next class will be on, okay, I'll tell you the timetable. You have an assignment in Cisco Packet Tracer, decentralized yeah, broadcast message from one network to another. ठीक है. So that's it for today. Thank you so much.
Thank you, sir.
Thank you, sir.